Thank you, Daniel. Is it working? Hello? Test. Yeah. OK, so this is the first time I'm presenting on fuzzing RTC systems, on fuzzing in general. I'm going to be describing two different approaches that my colleague and myself have tried, and we'll see how it goes. But first, I've already been introduced, so thanks, Daniel, for that. It's not just me, but it's my colleague Alfred also that I'm representing with this presentation. We've been working together when it comes to especially fuzzing RTC systems. So voice over IP servers and so on. And yeah, Alfred, he enjoys building all sorts of things, especially fuzzers lately. And so this is mostly his fault. Don't blame me for any of the crashes that we might report. I have to say that we are not C experts, although I will be showing snippets of code here. But yeah, we're basically learning as we go.
Like the rest of us.
Like everyone else, I suppose. So why present this? Well, I personally have been doing fuzzing for quite a while for other stuff, like email systems and so on, for a large number of years. But haven't seen a lot of fuzzing being done with RTC. So, we tried different approaches in the past 2, 3, maybe more years, but in the past 2 years is what I will be covering. And I want to describe how many times we failed, not each time, but just so that you get an idea, but also the few successes. So what worked for us when we did these experiments. But first of all, what is fuzzing? How many of you are familiar with fuzzing? Show hand. OK, so it's a little bit less than half, if you're all being honest. So I will just, display the Wikipedia page for the description for you. But fuzzing is a way to automatically test software by feeding it input, usually user input, that is malformed, that is possibly going to create problems for the software. And then also, fuzzing also involves monitoring that software for stuff that happens, probably crashes, but not necessarily just that. And why bother with RTC? Why bother with fuzzing real-time communications where, well, in my opinion, it's very critical infrastructure stuff. So if it crashes, if there's a security vulnerability, it's not only about leaking information, but also, as soon as the phone system goes down, someone has to fix it, right? And during that time, money, large sums of money, is typically being lost. So fuzzing RTC means that we can find such scenarios before they actually happen. And lastly, but also importantly, is that unlike other areas like HTTP servers and so on, RTC systems do not appear to be fuzzed by the security community. So we kind of wanted to do something that will give us more return on our investment. Look somewhere where other people are not looking so much. So the first approach that I will describe is, apart from, of course, we started by trying various different things. But the first approach that I will describe is focusing on a software package, a fuzzer called AFL, or American Fuzzy Lop, which is pretty cool. If you check out its trophy website, you have to scroll a lot to see all the software packages that they found security issues using this fuzzer. So it's been a very successful one. And it has a nice retro-looking screen, so what's not to love? Of course, there are some really important features. So one of the cool things about it is compile time instrumentation. When you compile the processes that you're going to fuzz, it has some sort of feedback mechanism to know, in terms of code coverage, where we are at, and how to modify the input that is being mutated so that it does even more code coverage. So it uses genetic algorithms together with compile time instrumentation. And lastly, it's very solid. So it's being fuzzed as well, but it's pretty good. It's pretty good. So how do you use AFL to fuzz RTC systems? Because AFL is really great when it comes to fuzzing, simpler tools, or just tools, command line tools especially, where you give it a file, the application loads it up in memory and probably crashes eventually. AFL is great for that, but to do the same thing with servers, it's kind of more difficult. So what some people have done is they've converted the servers to take standard input as if it's coming from the socket, and so on and so forth. We took a different approach. What we did was we started isolating different parts of codes that we wanted to target and wiring the code so that it can be fuzzed using AFL. And we had two different problems that we came across. So in the case of asterisk, the main problem that we came across when using this approach, or trying to, was that we had to, we wanted to fuzz, say, chen zip, so we wanted to just fuzz that part of the code. So we had to copy a lot of the asterisk code to initialize different things, and this was not so straightforward for us, at least. It's a matter of knowledge and experience with the project, of course. In the case of Kamailio, this was not such a big deal. On the other hand, it was more a big deal managing to build Kamailio with the AFL way of building, which was a bigger problem. We eventually managed, but yeah, I'm going to show some code which demonstrates what we did. But what we ended up doing after all this pain and horror is to just choose the easy way out, the path of least friction, and just fuzz libraries, which gave us some results. Something like PJ-zip is great because it has samples and so on. So that makes it much easier to fuzz, and pretty good documentation in my opinion. So to use AFL, you need, of course, corpora, you need samples. Yigiri is not here, but we have his zip packet here. So that's one of the samples that we fed into AFL. And then you need some sort of harness, which with PJ-zip, we did something like this. This is, of course, a bit butchered. We had to remove various parts so that it fits the slide. But it's something like this where we just copied the code from the samples and added the AFL loop over there so that it can run its course and do its job. passing the malformed SIP messages in the corpora to the modules, to the functions that we wanted to fuzz. And this gave us a result where at some point the fuzzer decided that this is a good idea to put a backtick in the boundary, before the boundary, and a different boundary. And it resulted in a crash in PJ-SIP, which we reproduced in asterisk, running channel PJ-SIP, of course. We did something similar with Kamailio, and so you can see the sort of code that we ended up with, but we did not find anything using this approach. At the same time, we were pretty frustrated, so we looked at, what else, how else can we tackle this problem? And I was familiar with Radamsa, so I suggested it to Alfred. Radamsa just is a very basic tool in a way, which mutates input and creates new input, which is malformed out of what you give it. It does some pretty intelligent things out of this input, but in the end, it doesn't monitor the process or do any of the genetic algorithm stuff that AFL does. So we started using Radamsa with just replaying SIP packets, and we immediately had a result. So if you feed this to PJ-SIP, which came out of Radamsa, you get a crash in asterisk running channel PJ-SIP. You can't see the script here, but it's very simple stuff. So you have a register message, and we're feeding it to Radamsa and just sending more and more, not even caring about SIP itself. Just replay. So what's interesting is that there was much less effort from our part as security researchers with, so-called security researchers / hackers with little experience with asterisk or PJ-SIP. But also, it's interesting that during these tests, we came across problems that did not allow us to fuzz the target software. Like channel SIP, the skinny channel in asterisk, for example, as soon as we started feeding it fuzzed skinny messages, it ran into an infinite loop that started eating up the memory and just crashes asterisk. We had a similar problem with free switch, and I'm not going to be describing that here because it's still a problem. So we should discuss. Anyone from free switch should come up and discuss it with me. So yeah, the channel skinny problem was like this. So you get a nice graph if you try to plot the memory. And of course, we worked with asterisk to get these things fixed, and everyone was happy. So we started looking at a different approach at this point, since we gained some experience, and we decided to look at a more smart way of fuzzing, as in knowing the SIP protocol and handling SIP messages as they should be handled. So in the end, we ended up with two tools, ES Toolkit and Gasoline, which are part of our internal tool set. Now, ES Toolkit, what it does is, it does a lot of things, but to be brief, it allows us to set up environments in Docker using a template for different software packages. So asterisk, we have a template for that, for building asterisk. And then it allows us to run that Docker image so that we get dropped in CLI or GDB, depending on what we want, be able to test different versions very quickly and switch across different configurations. And this is really useful when you're trying to find out if a bug affects different versions or if it's just a few versions. And then Gasoline, the fuzzer, which is kind of agnostic, uses Radamsa as its mutation engine because it's such a great tool. But it's agnostic to which mutation engine it uses. In fact, we are also using Zoof, and we will be implementing others, support for other mutation fuzzers. And it's just a minimal SIP and RTP library, which allows us to handle these messages and get pretty far throughout the SIP dialog, throughout the sessions that we want to create. So we tested various things, but not that many yet. Channel SIP in Asterisk, we did not have any results, even though the code looks pretty scary to look at, but to put it mildly. But we did not have any crashes there. I suppose many other people had previously, fixed their own crashes, and so it's at a stage where, where it's been tested so much that we can't. Yeah. So that's cool for ChanSIP, except that people want to get rid of it. So you've got PJSIP, which has no comments there, but we of course found a few problems there. We tested RTP proxy and RTP engine as well, with just the basic configuration, but we should probably test it a bit more. Kamailio, it led to one finding. We only tested the basic configuration. VoIP monitor, I'm not going to talk about that yet. But if there are developers from there, please, get in touch. And of course, our customers, where we had quite a lot of success, surprisingly, by sending proper SIP messages and eventually sending the mutated SIP messages, which of course I cannot talk about. So some public findings, things that we published. In the case of Kamailio, this is the SIP message that would reproduce the problem that we reported. This is the SIP message that reproduces another problem in PJSIP with the subscribe. It has to be a subscribe message. PJSIP again, null character over there, crash, and a very nice number over there. It also crashes PJSIP, the older versions, of course. And of course, again, we met more problems that stopped us from fuzzing. So we kind of report these as denial of service problems so that we get them fixed and we can continue fuzzing. So there was one issue where, if you send invite messages over SIP or TLS, not UDP, and because you cannot close the port, and just close the port without listening for the asterisk just dies eventually, very quickly on our lab environment. In live, it's a bit more difficult to reproduce, but it does work. So yeah, this approach was pretty useful, I think. Let me start the video showing a demo of Gasoline against Kamailio. Oops, sorry. Let me try. Oh, what's happening here? Did I do anything?
Are you fuzzing the inputs?
Let's see. Okay, so about that. Where is the mouse? All right. So the screen is not working. So after 6 minutes of fuzzing on Alfred's computer, you get a crash in Kamailio. It's sending SIP messages and handling the responses sometimes. Not in this case, I believe. So it's relatively efficient with little work. So what's next? Well, we're looking at other protocols, of course, because just looking at SIP is good, but it's boring to stick to just one protocol. So we're looking at stun, which brings us to WebRTC sort of world. We'll probably look again at the first approach. Having gained a certain amount of knowledge, I think we should definitely invest a bit more time there. But also, I think it's quite useful to look at vulnerabilities that do not result in crashes. It's harder to detect. You kind of have to know what you're looking for sometimes. So we have to figure that out more efficiently. But things like memory leak vulnerabilities, similar to the Heartbleed vulnerability, could very well exist in the SIP servers out there. So my conclusion is that using AFL kind of would have been much easier if the developers made it easier. So I think that approach can be really useful, especially using something like libfuzzer instead of AFL, maybe. So some open source projects are already making it much easier for security researchers and developers to fuzz their software. See Google's OSS Fuzz, which is a project where open source projects can be fuzzed using the cluster fuzz cloud fuzzer from Google. So I think that's something that Kamailio might want to consider in the future. A bit more about this idea is that, you basically follow the documentation that they have provided so that you make it easier for fuzzers to work with you instead of, against you. But the second approach that we took, which is more black box, for us as pen testers, is kind of more efficient because we don't always get the source code. In fact, we often do not get the source code, but still we want to test software from a black box point of view, and then send some options message every few milliseconds to see if the server has crashed or get some sort of interesting response. This is the way to get in touch with me. There's various different ways. I'm happy to discuss if we have time for questions.
Okay, maybe one question until we get Julian preparing, or two, depending. Julian, where is the next speaker? Here. You put this one. And question, you have a question? No? Who has question about? You don't dare to ask, I know. Okay, Armen.
This is pretty interesting work. Can I ask, how repeatable are the test scenarios for to replicate these crashing situations that you find? And would you think of them as being part of like a regression test or something else like that in the future?
So to answer your first question, we often, there are vulnerabilities or crashes that we find hard to replicate sometimes, but it depends on the case. It depends on what's happening with the memory. The second question, what was it? Oh yeah, I think yeah, some software packages are doing this as part of regression and continuously.
Okay, Sandro, really thank you also helping us to discover some issues with Kamailio.